Good morning or good afternoon again, and welcome to this joint Cloudera and Tunity webinar on ELDT, disrupting the traditional data warehouse approach. My name is Wim Stoop, and I'm Cloudera's Senior Product Marketing Manager for EMEA. In just a little while, after an introduction of Ted Orm, Tunity's VP of Technology for EMEA, you'll be hearing from Mark Bendel and Ranjit Aswal, both from N-Star Group. Yet before we get started, I wanted to cover a couple of things from a logistical perspective. First of all, we will be recording this webinar, and soon after it completes, you'll receive an email with a link to both the replay as well as the slides that we used today. Secondly, if you'd like to ask a question during this webinar, you can do so through the Q&A option in the webinar. We'll attempt to answer as many questions at the end as we still have time for. The third point is, if you'd like to speak more with either Cloudera or Tunity about this or any other topic, you can indicate this in the survey right at the end of the webinar. So with that, let's get started with a brief introduction to Cloudera. You may well be familiar with Clive Humby's quote in 2006 that data is the new oil. It's a very apt quote, and we're hearing it many times nowadays. Yet I think Piero Scaruffi he actually puts an even finer point. He's a cognitive scientist and also the author of The History of Silicon Valley. He says that the difference between oil and data is that the product of oil doesn't generate more oil, whereas the product of data, so for example, self-driving cars, wearables, drones, and all these things, they will generate even more data. And that's a situation that many organizations find themselves in, dealing with ever more and ever increasing volumes of data, especially in the area of IoT, an offshore oil platform, 1 to 2 terabytes of data on a daily basis, power turbines, 5 to 10 terabytes. Google's autonomous driving car generates about 2 petabytes of data per car per year. And this data enables an awful lot of things. And that's exactly what we're in the business in at Cloudera, because we believe that data, excuse me, can make what's impossible today possible tomorrow. And that's not just a cool statement that we have, it's something that we enable for our customers on a daily basis. The graphic that I have on the right-hand side here from NASA about the Orion space program that they have is one of those examples of where data is making that impossible possible tomorrow. They are embarking on a journey to take astronauts from Earth and bring them to Mars, but also bring them safely back. It's not something that they decide to do today and then leave next week. There are months and years of preparation and testing that go before that. And what's coming out of this? A lot of data telling them about the behavior of the capsule, data telling them about the systems, the telemetry as it is being put in orbit. And it's based on that information that they're able to complete this mission, not just bring man to Mars, but also bring them safely back. And we empower people, organizations, to transform all of this very complex and ever more voluminous and structured as well as unstructured data into very clear and actionable insights. We allow organizations to take data and take action based on that data. And there are some fairly typical areas within a business that this data can directly help. And starting from right to left, the first one is the protecting business risk and reducing the risk of doing business. And as you have seen in the news, it's becoming increasingly difficult as an ever wider range of new threats arise. You'll have seen the WannaCry worm, for example. So at Cloudera, we take that security of your data, all of your data, extremely seriously, and we build very specific solutions to ensure that it remains well protected. What's the other area? Well, connected products and services. The next then that we empower organizations to do is to connect all of the data they generate from their products and their services and transform that into actionable insight. And it's critical for an increasingly connected world, the Internet of Things, where everything and everyone is connected. So whether or not you're connecting vehicle sensors, kitchen appliances, or healthcare monitors, we can help with that. And the last area that we help in is something that every organization deals with. How do you drive customer insights? It's really easy if you want to reduce cost in your organization, but it's a lot more challenging nowadays if you want to grow your organization by selling more to more customers or more services to existing customers. It requires a tremendous amount of insight in the changing behavior and expectations that these customers have. So we collect and analyze all customer and prospective customer data so that you can understand and market better, sell better, prevent those customers that you want to keep from actually leaving. But of course, in order to do that, you need to have a platform, and we deliver that modern platform for machine learning, analytics, and optimize that for the cloud. That's what we do in Cloudera. We give you a platform that literally runs anywhere, and that type of flexibility allows our customers to run in the most agile and cost-effective environments. It's decoupled in architecture. We have cloud-native capabilities that make it gives you the ability for elastic scale to support different workloads on different kinds of infrastructures. And of course, you need this to be a platform that is enterprise-grade, so it fits securely, performantly, and compliantly in the existing infrastructure that you have. So that's exactly what Cloudera as a platform is. It helps those organizations become data-driven, take advantage of the one thing that makes them extremely unique, the data, but derive value from that. Now, we don't do that alone. We do that together with an ecosystem of partners. And one of the perfect examples of an organization that helps us and helps deliver solutions with that is, of course, Tunity. And with that, I'd like to hand over to you, please, Ted.
Many thanks, Wim, and good morning, everybody. Good afternoon. Many thanks for joining us today. As you said, my name is Ted Orme. I'm a VP Technology for EMEA for Tunity, and just a briefly introduction about who we are and what we do and how we're helping organizations and the team with at N-Star Group for making their data available with our flagship product, the Tunity Replica product. So in a nutshell, who are we? What is it? We're a modern data integration platform, helping customers, helping clients enable that modern data architecture, enable themselves and their organizations to be more data-driven. What do we do? We make data available. We bring the data out of operational systems. We bring your most valuable data, the data that runs your business, the data that is the transactional systems, the important components of that data, and we bring it easily into the platforms that you use today. And how do we do that? We do that through CDC technology. CDC stands for Change Data Capture, which is a mechanism for capturing those changes in real time as they happen, as the systems are creating that data, as the inserts and updates come through. We capture those, and then we make those available and move them into the most modern data systems, into the data lakes, into cloud, into Kafka, wherever those platforms are needed, wherever you need that data, that's where we make that data available. And why are we different? What is our key component? Is that this is our core competence. This is what we do. We are listed as being the Gartner listed as being the leading provider of CDC technology, supporting over 45 different sources and targets within one simple platform, one simple interface to bring value to your data, to get it to where you need so that you can get the best out of those platforms you're building today. And what are we seeing in the industry today? What are our clients seeing? These are the evolutionary stories from the classical data warehouse environments into more of a data lake environment, moving away from just traditional batch processing of end of day, end of week, to a more streaming architecture. And that's not always just about the need for real time, but it's just being more polite to your operational systems, getting the data out of those systems with a minimal impact on those so that they can be there for running the business, to driving more revenue, to running the actual systems that are important to your organization. And then where is that data? Either on-premise or in the cloud. We see more and more that cloud-first strategy for moving that data, for making it available. So they're the evolutionary stories that we see about how customers are moving to a more data-centric organization, to be more data-driven within an organization today. And some of the customers that we've been working with, we're very proud of our customer base and the customers that already use our technology today. We have 44 of the Fortune 100 customers, already customers, from large banks to car makers, telecommunications to manufacturing, all the different verticals. And Mark and Ranjit will dive into more of the details in the insurance industries that they're looking at today. But from understanding that data, everybody has that same need of getting the data into those data lakes, getting the data into those environments. And here you can see that most of them are in what I call a classical Hadoop data lake environment or a Kafka streaming architecture environment, of bringing all of the data. And that ingest challenge is the key. That ingest challenge is an 80-20 rule. It's fairly easy to get data into an environment, but it's very difficult to get it out of those production systems, to get it out of your Oracle, SQL, DB2, SAP, or DB2 I series or Z series, whatever the operational systems that are running the organization. We can get at that data and make it available. And this is where Replicate fits. This is where Tunity are helping organizations get their most valuable data into that modern data platform that they're building today, to show the benefits of the modern way of working, the more schema on read over schema on write, and of the analytics to discover, to understand that data, to get the data into the hands of your data scientists quicker so that you can see the benefit. And this is where I'm very, very pleased to then introduce Mark and Ranjit and the story that they tell about how we've combined both Tunity and Cloudera to offer that platform to give a disruptive process to benefit them as an organization. So with that, Mark, I'll hand over to you.
Thanks, Ted. Briefly, by way of further introduction, I'm Mark Bendel. I joined NSTAR 18 months ago as a lead architect, working on a large program of work with multiple projects. So one of those projects includes the solution that we're discussing today. It's a large data capability workstream. I'm also joined by my colleague Ranjit Afwal. I refer to him or call him Ranj, so if you hear that during the presentation, don't be surprised. Ranj has worked at NSTAR now more than 14 years, and he is the principal architect for the data capabilities project, which, like I say, includes the solution we're about to discuss. So I'll hand you over to Ranj.
Thanks, Mark. So before we start diving into ELDT, I just wanted to set the scene and explain the challenge, really. So whilst not as complex as a mission to the moon, an insurance company is a complex industry. It has many products, it has different channels, it has different markets, it has lots of different systems, each of which need to talk to each other. There are claim systems, policy systems, financial systems, actuarial and statistical systems. And all of these really need to work together to construct an insurance company. An insurance company like NSTAR grows through acquisition. So NSTAR is a company that operates in the run-off market space and in the live insurance market space. And over time, it's grown by consolidating these insurance companies into itself. And what that means is that it's taking on more systems, it's taking on more data, it's taking on more people. So as it grows, there is, jump back there. As it grows, there's an increasing demand for system integration and for systems to work together. So the challenge really is, how do you make the complex enterprise into a target state that is simpler to manage and easier to grow with as the enterprise grows? So you can't stop the enterprise growing, but you do need to be able to manage that complexity as you grow. So as you begin to grow, you start to notice that there's a demand for change, there's a demand for efficiencies, you need to use your existing resources more effectively. In effect, you want more cost-effective growth. And And so there really is a demand in the enterprise for using those resources in a more agile way, and in a way that encourages you to deliver solutions more quickly. So speed and agility within your enterprise are key things for successful growth of the enterprise and managing that complexity. But there are challenges to doing that. So it's a non-trivial. So data agility is a non-trivial problem for any enterprise. There are data quality issues that complicate in terms of a finance industry, how you reconcile all your financials because you want to be consistent across all your sort of delivery channels. You have shifting priorities in projects across the enterprise, all looking to achieve slightly different things using similar resources. There's an increasing regulatory framework which adds complexity to the insurance industry, and there are increasing compliance demands. And so successful delivery of any of these projects really depends on encouraging a better collaboration across the enterprise and improving how your teams are able to work with your business sponsors.
Okay, thanks, Ranj. So as the organisation grows and we acquire more systems, yes, we've looked to try and meet that complexity by doing migrations and consolidating platforms. Another method has been to deliver your traditional data warehouse. This is where really the ELDT concept comes in, because we understood that actually there are challenges with the traditional data warehouse solution. They are typically around how long it takes to deliver. You often identify data quality issues, but usually only right at the end. And then the time it takes to fix those issues and implement that change can again cause further delay. There's often issues with collaboration, and what I mean by that is actually getting the business and IT to work together. And because of that, we often then find that the business themselves, through necessity, go off and build their own solutions. So just exploring those a little further. So the time taken to develop the solution. So I've tried to look at this from two perspectives. One is the methodologies that we've used in the past, and the other one is constrained by the technology. We've often had to build a solution that's meant that we've got many steps in the architecture. So just looking at the methodology, often we'd have a paper-based exercise up front, and that's modelling and mapping, and that's often done without really access to the data, which has been a real challenge. Once that definition has been created, it's then often passed to IT, who then, with their heads down, try and deliver to their best abilities exactly what's been written on the paper, and then we ultimately find that when it gets to be delivered and shared back with the business, there are then a few issues because, of course, as I've mentioned before, there's often issues with the data and the quality of that. And then regarding the technology itself, well, we've often found that to make BI tools performant or to be able to deliver certain reporting capabilities, we couldn't just look at the data as it was stored in the source system in a highly normalized structure. We'd have to consolidate and conform that and often create a dimensional model, which I referred to on this slide as data marts. And that's involved maybe acquiring the data, staging it, working out what the changes are, then storing it in a common model, our ODS, put it in a larger dimensional model, and then specialize and taking aggregate values, etc., to support the performance of some of the technology we've got. All of this has resulted in often it taking at least 12 months to deliver anything that the business can use. Another big challenge is quality of data. So quite simply, we have to typically consider taking the full depth of data, so that's all the attributes, because the operational team need that, But from an insurance perspective, we also have to look at taking the full history. And when we go back and look at history, there are some real challenges, because we often find within our systems that over the years business processes have changed, or we've done previous migrations and we've really shoehorned the data into a system that then when we come to try and map to one of these models that we use for reporting and so on, it doesn't quite fit, and we have to build in a number of rules and accept some of those issues. Without being able to see the data during that process or getting the business involved, we tend to find that actually then when we deliver the product, there are issues referred to as technical faults on that slide. The other challenge which I mentioned earlier is the lack of collaboration, and quite simply this is where we've defined requirements, it's all paper-based. Yes, the business were heavily involved right at the start of the project, but then, like I say, it's more or less thrown over the fence to IT, and they will go and, to their best abilities, build exactly what was written on that piece of paper, and we'll find then, maybe 6 months later, when it comes for the business to start testing that, maybe the original business user who was engaged has moved on to another project. Maybe the business requirement has even changed. So there are some of the other challenges that we face. And I also mentioned, and this happens in every organisation, a frustrated business user often cannot wait that long for their solution. So they'll go and actually look to see if they can build their own products, and they'll often do that using non-standard tools. I mean, in every organisation I've ever worked, there's been a plethora of Excel spreadsheets and Access databases. The challenge there is there's often inconsistency between the different solutions and the rules that have been applied to derive certain values, plus the fact that we often find we're left with a key man dependency, and that key man dependency is also supporting a critical business process. So we'd like to actually move away from that, but we're not able to deliver a solution fast enough to meet the business needs. We refer to shadow IT here as cybercrime, but I'll move on, and as we see in the presentation, actually having the business defining some of their own solutions isn't necessarily a bad thing, and we'll look to try and embrace that. Okay, so we've defined really what the problem is within insurance and the challenges we have with the traditional approach of using relational databases and maybe even some of the methodologies we've used in the past. We're actually now in a fortunate position as there's new opportunities out there introduced through using big data technology. And I've just tried to summarise some of the key aspects with big data that will help us and have helped us define our solution of ELDT. So we've got a flexible file system. Fundamentally, what I mean by that is we don't necessarily need to model data before we store it. And we can store a real variety of data. We have a number of our systems that store XML, and we also know that from a company market perspective, we certainly receive a lot of our information as attachments within emails, and only a certain portion of that information within that attachment is ever recorded within the relational system. So if we could actually bring that original document onto the platform, which could then be introduced to the analysis, there's further advantages there. Schema on read, we'll come on to talk about that, but fundamentally that means we don't need to model anything before we store it. Parallel compute, accepting the fact that actually some of these schema on read activities can be very expensive in terms of CPU and memory. Well, we've got a system that horizontally scales easily. And we can store the information in one place and now support a variety of use cases, which is also, we're starting to discover, supporting innovation within the organisation. So I've just explored these, a couple of these in a little further detail. So the ability to store pretty much anything and everything, lots of different file formats, we refer to as full fidelity storage. And again, I refer to that schema on read, as in we haven't needed to model the data before we store it. We'll actually model that when we start consuming it. This has ultimately led to real simple data acquisition. Just the speed, particularly using tools like Tunity Replica to actually get the data onto the platform. And it's not we're having to choose which attributes we want because we'd have to model them and store them in a particular dimensional model first. We'll just take everything because it's actually much easier and simpler and faster. More power to the users. So all of a sudden, we've got now tools and technology that interface with big data, and we talk about a couple of products later on in the slides, Trifactor and Arcadia data, that actually are very much more now geared towards the business user rather than IT users. They can do the expensive schema on read type activities, can do the modelling within them. We've learned through experience that while sometimes you can do many joins within statements to produce a report, it's not always sensible, and there is some element of data preparation first, and that's been part of our learning experience. I've just highlighted there as well, just down towards the bottom, that actually it's starting to promote experiment within the data. Because it's so easy now with some of the tools and the visualizations to be able to slice and dice. And actually the cost of getting things wrong, because we've no longer had to write requirement specifications, hand it to IT and wait for the solution. We just do that now within at our desktops. The cost of getting things wrong now is low, and hence promoting experiments. So with these next generation solutions as well, even with within N-Star, we're now looking at, instead of the batch type architecture, moving towards now nearer real-time solutions. As probably most of you know, if you combine some of those real-time streams with some historical data, moving towards that Lambda architecture, now we can start building things like decision support solutions. And examples of that within certainly the company markets insurance are, we actually write through a number of different channels, and on each of those channels we could be effectively quoting for the same risk. And by actually storing what we've already quoted and what we're currently quoting, we can make sure that we don't get that duplication and any issues there. Plus, we can monitor underwriters' limits, exposure in certain areas, what we're currently looking to, what risks we're currently looking to take on board with what we've already got, and to see whether or not we've already exceeded our limits in that respect. And additionally, the document storage and the ability to actually now, as I mentioned earlier, have that much richer data set, as well as our relational data sets, and bring those together. We've already started looking at products like Solar and indexing some of these documents and exposing that out through an API and a web service to other applications within the organization. And one particular use case is, from a document storage perspective, we bought a book of business which came with 25,000 boxes of documents. And when a new claim comes in, we need to know whether or not we're providing cover, or we have that risk on cover. Now, in the past, that may have meant we'd have to trawl through all of those documents to properly understand that. But if we now look to start scanning and indexing that information, it's very much easier now to do that search. So there are significant cost savings that can be made. So I put this slide in as a bit of an analogy, just in summary, comparing the old relational database technology and those dimensional models and ODSs and warehouses, and I refer to them as more our old cow. Now the only problem I see now with this analogy is when I subsequently did a bit of research on how many stomachs a cow has. I think it has 4, but that's meant to represent the fact that the cow really can only ingest one type of thing. It's grass, and to actually consume and ingest the grass, it has to process it in many different ways. Whereas we move to our human, which I've compared to our big data, they can pretty much consume anything and everything, and it all goes into one place. Indeed, so much so that our human can even consume our cow. Just suggesting that actually we're starting now to move towards technologies that can do some of the relational type activities, and perhaps as again most of you know that we've got Kudu now, where you've now got inserts and updates as well as the reads. So we know what the problem is, we know the limitations of the old technology, we know now the advantages of the new technology. What did we decide to do? So we'll need to prove to the business that there's an opportunity out there for the efficiencies that we've talked about. Do that, working on the program I mentioned earlier, we seized the opportunity to actually get some funding and start doing a proof of concept. Now we time boxed that to 6 weeks, whereby we needed to get the software installed. In fact, first of all, find some hardware, and we found some old blade servers which are not ideal, but we had a half a dozen of those where we provisioned those, put them in a cluster, installed Cloudera's data hub, and then critically identified a challenge within the organization where we could compare and benchmark what we were about to do during our POC as a measure of success. The other critical thing as part of the POC was actually to ring-fence certain IT and business resources, because we really needed the business engagement. Because if we could demonstrate to them the advantages of this new approach and this new technology, then if we could get their backing, that would help us then put the business case together and move forward. During the 6-week process, we did a number of show and tells as to where we were, the challenges we were facing, but also we got the business to start presenting back as well to the wider organisation as to how they were benefiting with using some of this technology. I'm pleased to say the POC was very successful, and then as part of that programme of work and one of the work streams, we looked to do a product selection. We knew we needed a platform for where to store the data, and we'd already worked with Cloudera, and we knew there were some niche capabilities within that distribution that we wanted moving forward, and that's very much around the navigator side and the security side, and also some of the support that we'd received so far, and the fact that we were just around the corner made it very, very easy decision. Additionally, we needed to be able to bring the data onto the platform very quickly, and we'd looked at a couple of products, and actually during the POC we didn't use anything quite so strategic as a Tunity Replicate. We were looking at more one-off loads using tools like Scoop, etc. And once the data was on the platform, we'd recognise the fact that then get the business users engaged, we need some business user friendly tools. And then finally, accepting the fact that within any organisation there's still an element of conforming and consolidating data, and that had to be done in a standardised way with elements of auditing and reconciliation and various other logging. We wanted a more robust ETL tool, and we looked at a couple of leaders on the market there, Talon and Informatica as well. So I've just listed out there some of the activities we went through and some of the key requirements for that product selection. Like I say, I think probably the one to pull out there is we wanted tools, particularly from the business side, that worked with the data in its native format. We didn't want to have to, once we've got the information onto our big data platform, then start taking it off and loading it into then, say, SQL data stores and turning it into dimensional models. We wanted to be able to report on the platform itself, not least for compliance issues. As we were going through the product selection, we came across a number of different products. But I must say, we came also across some great names for some of the technologies. There's a Photon compute framework within Trifactor. We've got a Blaze engine within Informatica. We've got Cloudbeam, now a Tunity Replica cloud solution. And also an Arc engine in Arcadia Data, which are all products we ultimately ended up selecting. Not just because of those names, but for other reasons. So I'm going to hand you back to Ranjit, and he's going to describe now the actual ELDT and how that compares to some of the previous approaches. I'll hand you over.
Thanks a lot. So the platform there is now capable of supporting really a change in design pattern. I just want to revisit really what those design patterns are and why it is that we thought we needed a different design pattern or a slight evolution of one. So this is typically, what you would do in terms of an insurance industry or any finance industry. You would either construct your own data model, or you'll use one of the existing common design patterns in the industry, whether that's Inmon or Kimball, and there are others as well that are used. And they all follow a sort of similar design approach, where you really need to expend a fair amount of time gathering the requirements up front, doing a lot of big design up front so that you can then structure your program of work to implement the solutions that you have, and then finally produce the end result for the end user. And I've sort of depicted this as the little green guy who's sort of a stakeholder, and they really want some information. They've fed into your sort of project management process all the things that they desire. You've put out the mandates or the charters that are going to support that activity. And then you go down this process of execution, whereby you're sort of building the staging areas, you're building taking copies of data, building the staged environment. You might conform that data, you might model that data a little bit more, and then you may extract that data into a form that's going to be consumable by some BI tool at the end of it. And so there's a long gap of time there where the stakeholder had originally requested some information or some sort of objective, until they can actually see what comes out at the other end of the pipeline. And it may not be exactly what they want. They've not really been truly engaged throughout, because it's sort of been thrown over the wall to IT, and IT have now gone down the path of implementing what that stakeholder had originally suggested. And this time frame can be significant. It can be months to years before the end user can actually see the value of this. And Kimball is another sort of similar approach, where you sort of take on a more dimensional modeling approach, but the process is similar in its vein. So the alternative design pattern is ELDT, which stands for Extract, Load, Discover, and Transform. And it really is an approach that tries to change the way that we go about implementing the solution. And it drives a deeper collaboration with that stakeholder, so that you're sort of engaging them, doing the elicitation of the requirements, but you're also enabling them to change the requirements through the journey of producing the end product. So they constantly engage. During the extract cycle, when you land the data, they're able to see the information, work with the stakeholder, work with the people who are doing the technical delivery, change what they need, go into a discovery phase where they can look at the information and decide whether or not there are data quality issues that also need to be addressed en route to delivering a final result, or whether there's actually a new source of data that needs to be brought into it. And at the end, they are again engaged in the deliverable product, that they receive. But because they've been engaged throughout, they have a much higher buy-in into the entire process and the end deliverable than they would have done had they sort of just thrown it over the IT wall and said, can you build me this? And there's a greater chance of success in that sort of delivery model. So what does that practically mean, having discussed all the platforms and this approach, which seems, how we want to go? The way that we did this was to extract the data using Tunity Replica. So we have a number of source systems whereby there's SQL Server, there's Oracle, there's AS400s, there are flat files, and we just wanted to ingest this data without having to focus on the ingest. So we needed a really good ingestion solution. Tunity had a product called a Tunity Replica, and it can write into the Hadoop data structure Hadoop file system that we had set up. And it can write into the on-premise platform that we have, or in scenario of DR, we have a cloud platform, and we're able to then write into a cloud-hosted environment too. So the ingestion allows us to work either a snapshot or through CDC, and we get to tune what that ingest pattern is and quickly scale that out as we add more sources and more environments to the enterprise. We land the data into our data hub, which is based on Cloudera's data hub. It's an environment that allows us to collaborate more effectively, so we can land the data. We have a number of endpoints that allow for a better shared experience across the platform. Everybody's looking at the data in a similar environment. Our auditing and data lineage and security is all in one system. Typically, it's been in multiple systems. Every time we've built a data warehouse solution, you end up setting up security in all of those different environments. Audit trails are really difficult, and there's a lot of work to support that capability in terms of compliance. So Cloudera gives us one place where we can just land the data and start to work with it, collaborate with the data, and share the information. And to do that, we've needed a few tools to assist with the discovery element. So we really wanted end-user engagement, and we needed to choose tools that allowed for end-user engagement in a way that was friendly to the end user. So Trifactor is really good at this. It's a fantastic tool for looking at the information that we've landed into Cloudera without having to be very technically savvy. You don't have to know how to do stuff on the CLI. You're presented with a web interface, and for the consumers, it's a way for them to collaborate more effectively with the technical teams. It allows them to then generate a data set, a minimal data set, just to produce exactly what they need. They don't need to produce something that really satisfies the entire enterprise worth of attributes. They just need to produce the data set that solves their business problem. Arcadia Data is a reporting tool that allows us to quickly look at that data. So we're using Trifactor, push that data into Hive, hosted on Cloudera. Arcadia can then quickly enable self-service for the end user. And this is all being driven from the end user perspective. The end user is able to see the data that's landed on the data hub. They're able to modify the data and produce the data sets that they need to work with using Trifactor and publish it to Hive. And now they can actually produce reports straight off the back of that without having any IT intervention whatsoever. Now, there may be a need to do some IT intervention if there is something particular technical that they want to be able to achieve, but they've been now at least given the opportunity to produce the data set that they're really interested in. Once they've produced the data set, they've produced some reports that prove the value of what they actually want to achieve from a business perspective. They're now in a position where they really want to sort of operationalize this and put this into a production state. And that's where we're using tools. We're using Informatica. It's a tool that allows us to take the information about what was produced in the data set, knowing all the lineage information of where that data was being derived from and the type of end product reports that were produced to prove the data set, it really increases the chances of that transformation producing a technical output that is going to be used effectively in the business. And it gives a narrower scope, if you will, for the technical work. The technical work can remain completely technical. It doesn't have to start to make assumptions about the business and how it is that they want to do that. So this is an illustration of all the components. We have Tunity Replica. It's ingesting data from our enterprise from various data sources. We're taking the data, we're landing it into a staging directory, if you will, within the Cloudera data hub. That exposes the information to end users through tools such as Trifactor or through Arcadia. So we can look at the raw data through Arcadia as well. We don't necessarily have to transform it. And we can offer the end users a sandpit environment. So within the cluster, we can construct a space where they can work, and they can work securely so that the area is governed more effectively. And importantly, once they're finished doing the work that they need to do and they've operationalized it and they no longer need it, we can reuse that same resource and the same server spaces for other projects and downstream projects. We don't have to start spinning up new servers for that, to support that. We can scale with the business, up and down. As we produce reports through this data discovery phase, we rationalize what we want to be able to produce for the transformation areas so that we can more effectively hand over to an IT function. They will produce transformations that will follow a more typical ELT-like process in Informatica to land the data sets in a more operational way, so it's produced in a more reliable way, running every day or every week or every month. It's auditable, it's secured, and it's more operation ready.
Okay, thanks, Ranj. So we've looked at ELDT. Probably some of the messages that we'd like people to take away are, when it comes to the T part of ELDT, I would suggest that you actually focus on the core high-value attributes, because whenever we've done data warehousing, both Ranj and I in the past, if a product's ever succeeded, it's been where there's been a narrow focus, certainly in the first instance, and then you build on that subsequently. You tend to find that that core data set is the thing that needs that robust, repeatable execution versus what might be required within a department where there's more flexibility as well needed. So you don't want to build something that isn't as easy to change going forward. So can you just move on to the next slide for me, sorry, Ranj. Okay. We talked earlier about shadow IT, and I think probably the message, hopefully, that you got from Ranjit is the fact that what we're really trying to do is develop solutions or develop a platform that encourage the business users and their engagement, collaboration with IT to start building the solutions for themselves. So arguably shadow IT doesn't exist anymore. I've suggested here that we're embracing it. We're actually bringing the business and making them part of our team. I put there as well, while we want to allow the business to go off and develop their own solutions, there still needs to be an element of governance. Where we've got values that require some form of derivation, there's rules, measures as an example, we want that to be consistent, as well as the definitions that people are using and some of the terminology. So recognising this, what we did at NSTAR is we built that business glossary, data dictionary, call it what you like, that is used as a reference now for those users who are going and building their own solutions. So some of the benefits of ELDT, well, hopefully you can appreciate that we can now deliver solutions much more speedily, which itself introduces significant cost savings. There's better data quality, The business users themselves are very familiar with the original source data and some of the rules that need to be applied to bring that together. And actually, by bringing the business as part of the team, we're able to deliver more. So it's effectively freed up the IT resource to focus on that core data set which we mentioned earlier. And the businesses themselves, self-service, they were doing that anyway, but in their own little silos in the past, if you like. So, one thing probably worth mentioning is the platform itself. We've been able to pretty much meet some of the compliance requirements out of the box, as well as working on the program of work that I mentioned earlier. I also now have started working on the GDPR project, and we know that we've got to make sure we are auditing who's got access to what. The data's secure, so with Cloudera we've got the options, and we're introducing encryption on the platform over the coming months before the end of the year. It integrates with our Active Directory. Navigator itself provides us with the data lineage. So we've actually got some significant quick wins through a lot of that. So what have we done? So I'll just hand it back to Ranj, and he'll just describe, over the last 12 months, briefly what the journey's been, what we've delivered. Take from there.
Yeah, so we wanted to deliver some value out of this beyond just setting up a platform and showing that there's a new approach to solving a lot of the problems. We wanted to actually go ahead and start to do this in real life. So we've gone ahead, we've produced underwriting MI, we've produced claims MI to support a migration that we did internally from one policy system to another. That was a key part of the deliverables that we want to meet, had to meet. That's now running in production. We're able to do policy analytics on that and reproduce the claims reporting that we were previously doing on the prior systems using this new approach. Policy search, we have an integration between a policy system and a claim system. The claim systems need policy information. We want to be able to produce a model whereby the claim system was policy agnostic. We produced a mechanism by which this was possible using the data hub to consolidate all the policy information and providing a mechanism for the claim system to search the policy platform using Solar as the engine that runs the search aspects of that. Actuarial pricing, so we're analyzing at the moment information in terms of the data that we ingest. We're looking to run stats on it to drive more value out of the information that we have. In the US, we have a large workers' comp line of business. There are a number of outbound regulatory fees that we have to be able to provide. The process of providing those unique data sets involves producing a piece of information specifically for the entity we're delivering to. So in each of those scenarios, we use this design pattern to focus on just the things that we need to deliver for that particular purpose. So these are all now actual working things that we've got running.
Yep. Thanks, Ranj. So just want to summarise and maybe actually share with you some of the lessons learned and how we actually have looked to try and address those during the last 12 months. So maybe you can appreciate there's been a bit of a skills gap. So we've come from a SQL Server integration services background. Additionally, the business we're using tools like Access and Excel, and moving now towards a solution that is based around scripting. We actually mitigated that through a lot of the WYSIWYG type tools. So a Tunity Replica, for instance, no development required really. It's configuration, brings data in, we start trapping even change data capture in the change history, and that's then available to tools like Trifactor It's a code generator. It's actually writing, originally it was pig scripts, now it's writing Scala scripts and executing Spark on the platform. And then again, Informatica, we chose that certainly to support our development team, because that's got more of a graphical user interface, and you're not actually scripting, it's generating the code behind the scenes. Been a real paradigm shift within the organization. So now moving away from that, throwing it over the fence to IT for them to deliver something, there's more engagement. The other paradigm shift really is the modeling aspect. We're not modeling things in the way we were before. Actually, it's really now producing large data sets, real denormalization activities rather than anything else. And we found that that works best with the tools that we've got. Educating the organization, you know, that's more around, we've actually set up a number of training courses to bring people up to speed with these tools and technologies that we've selected. And then one of the other key aspects is the DevOps wasn't really a role that we had within the organization. We had a lot of Windows servers, and our operations and application support team supported those. But now we need someone with those Linux skills, as well as the ability to dip into the applications themselves, such as Cloudera, Trifactor, and so on. And actually, when we need to apply an upgrade, when something's not quite working, to delve into the logs, to actually, you know, do that activity. And that's a new role that we've identified within the organization. So Wim, just to mention, I think that's probably the end of our presentation. I don't know whether we've got time for any questions.
I think looking at the time, unfortunately, we won't be able to answer all questions, but we do have a few that I think are pretty quick fire. What are the tools or the products that you use for some of the data visualizations?
I'll hand you over to Ranj.
Yep, so we use Arcadia Data for our data visualization and producing dashboards, provide self-service BI, but also producing more technical delivery sort of reports from that end of it. We are still in part a Cognos shop as well. But importantly, Arcadia Data gave us a mechanism whereby we could use the sort of push-down optimization of Hadoop and sort of benefit from the power of the cluster as a whole. So Cognos is sort of getting there, but Arcadia sort of allowed us to engage self-service BI pretty much immediately.
Excellent. That's really good. Another question. What kind of extraction does Tunity support? And this is perhaps a question to you, Ted. Is it the same as a combination of Scoop, Flume, and Kafka, or how is it different?
Well, we know we can use
there were a couple of sorry, Mark. There were a couple of questions just on CDC there. So really, Tunity are all around that CDC component for change data capture. So capturing the changes from operational systems, but we're doing it quite differently from other technology. We don't actually need to install any software across those operational systems on Oracle, on SQL, on DB2, iSeries, Z-Series. So we're just looking at the logs, and as the changes come through, as the commits and as the transactions, we then read that off the log and push it into any of those target systems. So it gives you the first time you run the task, it gives you the full history of all the data, and then the changes with a full before and after image of every transaction that then can be consumed by the technologies downstream, as explained by Mark and Ranjit. So just getting data out is the key component, making that available to that modern data platform wherever it may be.
Wonderful. Did you want to add anything to that, Mark or Ranj?
Yeah, I was going to say, actually, we found it can write to a file stream, so we can write it to files, we can write it directly into HDFS, or we can actually push it into a Kafka queue. So there's definitely options there, and we're exploring all of those. The key thing is it's just configuration.
Okay, wonderful. And I know we're nearly at time. One more question though. Tunity, is it just a near real-time data replication tool?
I think real time is sometimes the wrong thing to explain. It's the fact that we're capturing the changes as they happen out of operational systems and then making them available. The business case doesn't always have to be for real-time queries and analytics, but it's the most polite way to get data out of operational systems, rather than doing your nightly batch like a scoop job, which is going in there and hitting that production system to grab all the data and then move it. So that CDC component means that we are capturing the changes in real time, we're capturing them as they happen, but how you consume them downstream, if you're streaming it to Kafka, then that's a real-time use case. But if you're streaming it, moving it to Hadoop for processing, then the real-time is more the mechanism for capturing it. And it scales across multiple systems. We also have a sort of an enterprise manager that manages interfaces across an estate of servers. We scale up to some large organizations that have thousands of servers that we're integrating and pulling data into the cluster itself. So whatever those operational systems, Oracle, SQL, DB2, and now also SAP, the SAP data as well, we can actually get the knowledge of that data out of SAP directly into the modern data architecture.
Wonderful. Thank you very much for that, Ted. Okay, we're over time now. I'd like to thank Mark, Ranj, and Ted. Thank you very much for the extremely insightful presentation. Thank you to the audience for taking part. Unfortunately, we were unable to answer all of the questions, but if you do like to meet with either Cloudera or Tunity at the end of this, then please indicate so at the exit survey for the webinar. And with that, thank you everyone for taking part.
Thank you.
Thank you.